Thanks everyone for joining today. I really appreciate your time, and it's good. Today we're going to talk about a new project we started at MITRE called MITRE Embed. We're going to give up. This is a public webinar titled "Designing Secure Devices and Embed's Role in Mitigating Threats." Who we are first? I'm Adam Hahn. I'm a principal critical infrastructure security engineer at MITRE Corporation. Previously. Been involved with other projects like MITRE ATT&CK and have been working a lot with different critical infrastructure operators, including energy sector, rail, maritime, and water sector organizations.
And I'm Wyatt Ford. I'm an engineer and manager at Red Balloon Security. If you're not familiar, we're an embedded security company that provides expertise through our products and services. We have customized solutions to enhance embedded device security across critical industries, and we also are experts in analyzing and reverse engineering embedded systems. And we were part of the group that worked with MITRE to flesh out the embedded threat model. So I'm excited to talk about it today.
Thanks, Wyatt. Yeah, so and really, when we talk about embed, why do we start this, right? And so, we talk to a lot, and we know following if you follow a lot of threat intelligence, we know there's increasingly cyber threats targeting critical infrastructure, and looking at a lot of the critical devices used to support these infrastructures, we're seeing more threats targeting them, more sophisticated threats. We're seeing more and more vulnerabilities being designed, and a key area, um, organization here, the device OEMs, they really need to think about, when they develop a device, how long is it going to operate? It's going to be operate for maybe a decade or more. And they really have to think through, what threats are going to be feasible in that long lifespan, and how do they properly ensure the right mitigations are installed. Similarly, asset owners, are buying these devices, have to include them, integrate them into their architecture, and commit to operating these for, again, a long lifespan, decades or more, and they have to really understand, like, what's the risk of these devices, right? Because they have to really design mitigations and architectures around them, but often they don't really understand that. So, we really need to understand, how do we develop devices that have more kind of secure by design, and are we have more confidence in the security of them, and asset owners can use them, and better design architectures around them. So really, that the concept of MITRE Embed was introduced really by Niall Little and Thunder Pearson, who was on the call here too, and brought it to us, and really thought, can we work on something that really helps encourages the secure by design development of the devices, and provide organizations better understanding of cyber threats to these devices so that they can make better decisions. And so this is kind of a conceptual overview of what we're trying to do with Embed. At the core of Embed is an enumeration of kind of cultivated cyber threats to embedded devices. So we really try to understand, what are ways that threat actors can target embedded devices, and what that includes is that can include things like adversary techniques that we see in MITRE ATT&CK. So if you're familiar with MITRE ATT&CK, that includes, real world adversary behavior. And if those behaviors target embedded devices, we pull those into embed. One of the real kind of new contribution here is that we really want to think out much farther about, like, what threats might be targeted in the future. And so we're looking into what research in either a theoretic or proof of concept stage has been demonstrated to these devices. Often this knowledge is really distributed across a large number of different research papers, conference talks, blogs online, and it's really hard to get a really full view of what research has been demonstrated, what threats are really out there. And so really Embed kind of takes all of these and puts them together into a single data source, so that organizations trying to make this analysis can really have a full view of those threats. And then, really what we want to do is help organizations understand when these are these threats going to be relevant to a device. So every threat we look at, we then enumerate a set of device properties or features or capabilities that would determine, when should you consider that threat? So is that threat targeting a specific type of hardware, a specific design, architectural design, a specific type of software, a specific network function? That the idea is that we want to help people understand, what are the functions of the device, what threats are relevant to those functions, and better use those device properties to better understand and prioritize what threats are relevant to that device. And then we really want to ultimately encourage, the kind of secure by design mitigation. So how do we think through what mitigations need to be integrated into a device? So every threats are mapped to a set of mitigations. And those mitigations, are really encouraged to be incorporated in the device to help mitigate those threats. And so we'll kind of walk through this examples of what these are, these properties, cyber threats, and mitigations throughout this presentation, and give you a little bit more example of what the site looks like, how we intend these to be used, and some case studies for this. Um, uh, in addition to the cyber threats, we also try to map to other key knowledge bases like CWE to better describe, what kind of the weaknesses that might enable that within the device, or CVEs if there's examples of other embedded devices that have had these issues. And these are really just intended to help, encourage organizations to, identify that, if you don't address these, you don't want to have a device end up with a CVE, which is often very costly, and encourage, provide evidence that can support why, these are things that should be uh, uh, prioritize and why these mitigations are important.
Right. And so if we think about the use cases, if you reflect on what Adam just described, embed at its core is enumerating device properties, mapping those properties to threats uh, that the device has because those properties exist, and then mapping it to mitigations. This cuts across three broad use cases, and I think this common language across these three use cases is one of the core strengths of embed. So if you think about the users of embed, primary user are device OEMs, uh, another user are security researchers and testers, and a third user group are asset owners. So device OEMs can use embed to support threat modeling and in development of devices by looking at what properties are introduced into a device for its specific use case. They can then systematically work through these are the threats that those properties expose, and these are the mitigations that industry and the world have that can mitigate those threats. So this can be used for introducing mitigations today, but also to inform a roadmap for the next 5, 10, 15, 20 years. And we're going to dive into a little more into these use cases later in the presentation. The second main group is security researchers and testers. And this is an area where embed thrives. If you noted, Adam mentioned that we use as source material not just attacks that have been observed in the wild, but also research that's being done into security. There's a lot of great research into state-of-the-art and edge-of-the-art exploitation techniques, and researchers contribute to embed because that research is used as threats. A threat does not have to be observed in the wild in order to be a threat that's relevant to a device. Security researchers can also use embed as a way to map the work they're doing to language that asset owners and device OEMs can understand and integrate into product lifecycle. So that's the security researcher kind of user. And the third one is asset owners. So, and I think, Nayo maybe later in the presentation can speak to it, but asset owners have a very hard job. They need to buy devices and support acquisition and running things. And Embed intends to provide a framework for systematically thinking about mitigations that are in the device and understanding how introducing a device into an environment could impact potential security.
Oh, okay. So now we'll walk through. That's kind of a great walkthrough of like how we think embed can be used, who are the entities that can use it, and what are some of those use cases are. We'll spend a little bit of time to just give a brief overview of what's actually in embed, and if you have a browser up, just go to embed emb3d.mitre.org. Embed's a publicly available and free knowledge base. So feel free to take click through along with me, but. The kind of the core, as I mentioned, is an enumeration of threats to embedded devices, and so these are kind of hard to fit on a page, but we took a try. These are kind of broken down into more hardware specific threats. So threats looking at side channel type events, manipulation of extraction of data from hardware, doing things like intercepting data on buses. So really threats targeting and manipulating hardware. There's also a set of threats focusing on software. So on the system software, which is more looking at the bootloader and some and firmware and operating system, and even some cases like containers and virtual machines. So looking at kind of how those different the boot chain can be manipulated, how malicious code can be injected into the operating system can be modified, how firmware updates or update processes can be manipulated. The application software area looks at more, again, the higher level software, like specific applications deployed on the device. Again, looking at, especially looking at things like how programs are sandboxed, how threats to sandbox environments, threats to, a lot of authentication and credentials, threats to application specific protocols like HTTP, or even common functionality like the ability to load programs on a device, which is common across a lot of embedded device functions, including things like PLCs. And then we also have networking threats looking at unauthorized or connections, unauthorized messages, denial of service events as well. So there's a number of threats across there. Um, and what's in a threat? So as again, so each thread, if you click on any thread ID, there's going to have an identifier, like a TID, a unique identifier for that, a short name, a description of that threat. But then really a core thing to each threat is the threat maturity and evidence. So the threat mature threat starting first, I guess the threat evidence. Every threat we put in there, we do it based on some proof of concept article, paper, presentation that described whether that threat was demonstrated. So that could be a research report, it could be a mapping to an attack technique if that was observed from the wild. So the point is this is it's very much a evidence-based knowledge base, right? So everything is based on a paper, something describing that threat. And then since we know that some threats are maybe more concerning, like threats that we're seeing adversaries use right now are a little bit more concerning. So we have categories of maturity. So observed adversary behaviors are ones that we're seeing threat actors use today, like they're an attack. Known exploitable weaknesses are threats where we see maybe people exploiting those in other domains, but not in embedded devices. Proof of concept is something that we've seen a paper or a research report demonstrating a threat, but we haven't seen a threat actor execute it. And theoretic is something that we don't have a proof of concept yet, but maybe is a feasible threat. And so the idea is we want to, again, take all this threat evidence in a single and cultivate it so that people can really understand what research has been demonstrated or advancements have been demonstrated in these threats, but provided these maturities so that people can understand which ones are more like what we're seeing now or which ones are more likely to occur in the future. Um, and then in addition, every threat, where possible, has a mapping to a CWE and CVE, as I mentioned before. And then the key thing that we're really trying to do here is highlight mitigations. And so there's each thread it's going to also have a set of mitigations. And I'll take a little bit of time to dive into what those tiers are. Um, So, a mitigation, right? So the mitigation, again, every mitigation is going to have a mitigation ID and a name for that mitigation. And then there's going to be specific tiers. And I think that in a couple slides, I have a kind of more of a broader definition of those tiers. But there's going to be a description of that mitigation. Often that description kind of describes, kind of overview of that mitigation. And sometimes it'll discuss other kind of caveats or limitations of that mitigations or other key notes that should be addressed, I thought of when adopting this. And then we're also doing mappings to relevant control families. And so our first release of Embed just focused on the mapping to 64443 4-2, which is something heavily across a lot of industrial control system products. And the idea is that we know a lot of both asset owners and OEMs are aligning a lot of their organizational policies and procedures to 62443. And so we want them to be able to understand, if I'm trying to meet a specific 62443 control like this 3.14, which embed mitigations help me meet that. So we're really trying to align this with other standards families so that, they can use it in alignment with existing organizational processes.
And one thing just to add, Adam, like as people are reviewing the embed mitigations, I think one thing that's very important to highlight, and this is articulated very well in the white paper, which is on the embed website, is that the focus of mitigations for embed is introducing mechanisms into the embedded device itself to reduce the impact of the threat. And so this is in contrast to environment environment-specific deployment of other things to reduce a threat inherent to the device. And so the white paper makes it very clear, guidance that a device should be isolated from other devices in the network. While that might be a mitigation that helps reduce the impact of a vulnerability inherent in a device, that is not a mitigation that you'll find embed. Neither will be active network monitoring to detect threats. In order for a mitigation to be part of embed, the name really says it embed. It needs to be embedded within the device itself. And this, through the foundational, intermediate, and leading mitigations, is where embed can really have a large impact on informing product security roadmaps to introduce these mitigations into embedded devices. So we don't need to be putting out guidance saying unplug the device from the internet or put it in a lockbox and it's secure.
Right. Yeah. Great point. Yep. Exactly. We're trying to really encourage, identify those mitigations that can be, done more at the design time and really reduce the effort of a lot of these asset owners, which, often don't have the ability to deploy a lot of these mitigations or, especially, do anything after the device has been initially deployed. Um, And and back to kind of the content of mitigations here, one is a set of references or articles supporting explaining that. So we, we want to provide mitigations that, can be taken and integrated into devices, right? And so we want to provide a collection of really technical, detailed discussions about how to implement some of these mitigations. So here, example of, with Secure Boot, we have examples across different platforms like UEFI, across different hardware like ARM, guidance provided by key organizations like Microsoft and NSA and Intel. And so the idea is that, we want to provide a lot of guidance on how to do this, implementations that have been demonstrated for real world devices and different hardware, to really help organizations developing the device incorporate these. Um, so every mitigation has a list of references, and then also in some cases a mitigation might apply to multiple threats. And so a mitigation page down below here, like if this is a secure boot, there's a number of potential threats this could be also useful in mitigating. So it could be, bootloader and inadequate bootloader protection value verification. It could be, at the operating system with, malicious OS kernels. It could be supporting unauthorized firmware installation. So, or even it could be at the application level, or if preventing the modification of application level binaries. Um, so the goal is to provide a lot of guidance and detailed knowledge about what a mitigation is and what can be done to implement that mitigation. But as I mentioned before, mitigations are split into are tiered across three: foundational, intermediate, and leading. And really the goal here is to identify mitigations that we think can be easily deployed, within devices, and that are much more kind of mature. And so by mature, I mean kind of broadly used within industry and more likely to be implementable across different devices. And so that's kind of what we call the foundational tier. So the foundational tier are things that are kind of the minimal difficulty or capability that can be deployed, but something that we think is already broadly adopted across industry. So when we look at tiering these, we look at kind of three criteria. We look at is there demonstrated feasibility? Like is a do we know other devices, embedded devices, implement that mitigation? So a foundational one is one where we see that mitigation implemented across many embedded devices. Um, we look at, is there an open design? Is there a public documentation? Is there a artifact? Or is there architecture that describes how to do that? Like, can you go and find guidance on how to do this, really technical, good guidance? That's also a requirement for a foundational. So we want to know that this is feasible, that there's good instructions that show how to do this, and then there's also, we don't want this to increase any other hardware or other complex technical dependencies. So if you need to modify your hardware or you need to integrate some other sort of proprietary technology, that's going to prevent organizations from adopting this. And so when we look across mitigations, we identified these foundational ones that we think, are things that work on embedded devices, that there's information on how to do this in the public domain, and that there's not these really overly burdensome technical dependencies that would prevent inhibiting this. So that's why we call it foundational. We think that means these are going to be more feasibly implemented on many devices. Um, there's a lot of course, mitigations that are more difficult than that. So the next layer up is intermediate, and these are things that often maybe have demonstrated in other domains like embedded or sorry, like mobile or enterprise, but may have introduced like other costs or challenges within embedded devices. So demonstrated feasibility. We're saying there may be in other sectors. They open design. They might not have sufficiently well documented artifacts like maybe people are doing it in, in an iPhone, but it's not really clear how you would do that in embedded devices. Maybe it requires additional hardware or maybe some sort of complex software or proprietary technology. So you just can't immediately do this. You might have to think about a redesign to the device. You might have to think about how you would do this on a next phase of a product, right? And then leading is really focusing on more novel mechanisms that haven't been broadly deployed. So these are often a little bit more like research-oriented things. So there may be more like proof of concepts exist. The design might just be a research paper demonstrating a one instance of this, but not really showing how it can be broadly implemented. And maybe it could require a lot of complex development, technologies, hardware, maybe that is in the public and commercial space right now. So the idea is that I highlight these foundational mitigations that we think can be broadly adopted, but we also want to try to understand like what's the next best thing you can do once you've identified foundational. How can you identify more advanced and more improvements across them, and then and as these things become more adopted and more well documented, we're hoping that some of the intermediate stuff will, kind of eventually move to foundation. And as some of the leading stuff becomes more and more um, better research and better documented, again, that can kind of move down to foundational. So we hope these kind of tiers, or kind of plan these tiers to be kind of flexible, that something's not going to stay in a tier forever. It might move as that kind of technology matures.
Let me add one thing. So the intent is that, and hey everyone, this is Niam. The intent is to raise the security floor within embedded system devices. If the lifespan when they go is anywhere from 10 to 50 years, then we have to move exponentially. So we need to turn the dial on the actors and keep turning the dial on the actors. And that is why those tiers and that iteration of going from leading then becomes intermediate, and then intermediate becomes foundational is so critical. And it's critical for us to get the feedback from the community and the ingestion and the constant iterations to keep that going. But that is the intent, to keep us turning the dial on the actual actors rather than constantly playing firefighter and responding to this. Thanks, Adam. Go ahead.
Well, thanks. Good point, Niall. Yeah, and so just kind of showing how do we think organizations should start thinking about and adopting mitigation. So I've really hope that organizations look and try to broadly address foundational ones first. I mean, these are the ones that we think are going to be the most effective and are going to be the easiest to adopt, and then start go from go and explore higher tiered defenses or mitigations after that. So, just as an example here, we have a threat about device allows unauthorized firmware installation, and the foundational ones are, you could software would be software only bootloader authentication. So if you have some sort of firmware, it should at least be authenticated when it's booted, when it's installed or booted by software with some sort of, key mechanisms in software. Uh, and there should be some mechanism to ensure that the firmware includes associated signature and is secure when it's deployed so that it can that bootloader authentication can occur, right? Um, but ideally you'd want to move up to software-based bootloader authentication has concerns if like keys are extracted or from devices or modified, and so there's obviously it's better to go to hardware, but a hardware-backed bootloader authentication. So moving up that tier from an intermediate or foundational to an intermediate, but that introduces a hardware dependency that is going to be more difficult to deploy if a device doesn't have existing hardware to support that, right? And so this just shows how example like there might be a mitigation at a foundational mitigation and then a better mitigation at a higher tier. Um, there's an example where some of these are kind of incremental, where hardware-based bootloader authentication is better than software-based. Um, in some cases, uh, a higher tier might not always fully replace a lower tier. There sometimes the lower tiers and intermediate tiers can be used complementary, and sometimes they may address a little bit different element of a threat, right? So you might see things like ASLR and control flow guard together in addressing kind of the same a threat of buffer overflow exploits in a slightly different way. So they might be both in there as different tiers, but they're intended to not to be used together rather than incrementally. So that's kind of an overview of what we're really doing with embed, what the content, what the threats really look like, and really how we're trying to structure and incorporate mitigations in there. So we'll spend a little bit of time now walking over some use cases about how we see embed being used. In many cases, we're working with organizations that are actually adopting some of these practices, so we've been really happy to work with these organizations and walk through them and learn kind of how they work. But just kind of want to broadly share those at a high level. And really one of the key ones that we really wanted to encourage and adopt is how do we use embed for threat modeling, right? So uh, that's something we really wanted to influence how do organizations do threat modeling. We recently posted a blog post about, a lot of organizations use Stride for threat modeling, which is kind of an inherently a subjective process based on, the knowledge of the teams and their background, and really think that Embed provides a much more way to do like repeatable and more evidence-driven threat models, because it incorporates the same single knowledge base of all embedded threats. And so the idea is that you can take a device, you can enumerate what the device does, what are the components, properties, and features of the device, uh, and then understand based on those what threats those expose, since all threats in embed are mapped to properties. And then once you have that set of threats, you can then identify, prioritize those threats, and then identify, what are the relevant mitigations, how to prioritize those, and how to implement those in the device. So really, embed is kind of the notion of the properties, threats, and mitigations are really streamlined around this notion of how to think through threat modeling and how to use these threats and mitigations to understand where they're most critical to apply to a device. So just as an example, if you have a fictional device here, if you look at what that device includes, it's going to include some application level software, different runtime environments, application logic, could be web servers, databases of users or other data. There's going to be system software, specific kinds of, memory management mechanism, drivers, hardwares, components, firmware, operating system. networking functions. There's going to be hardware, different types of CPU, types of RAM, IOs, JTAG interfaces, and different networking functions, right? And so the idea is that if you take a device and enumerate those key components, there's a set of embed properties that map to those. And so there's actually a page on the embed site where you can actually go, and this is a screenshot of that, and you can go and ask. There's this is on the left here is an example of some of the embed properties. So PID 31 is, does the device have application software running? Is that, and then 311 was, is the device include the use of web or HTTP applications? 312 asks about specific program languages and libraries. And these are properties, and they're often nested properties. So asking questions about different sorts of application language will bring up other things about specific types of programming languages, specific languages that lack memory management. And each time you click on these, it's going to map to a thread, right? And so the idea is that you can follow along these embed properties. If you understand the components of a device, select which ones are relevant to the device, and that's going to select a set of properties. And so the idea is that by understanding and decomposing a device, mapping to the embed properties, you'll get a set of tailored custom threats to that device that are really specific to what that function or capabilities of that device are. And kind of how we view this being used is, so we worked in our use case early on with this, where we did the same process, and we worked on like a fictional an RTU device we had in our lab, right? So we had done a lot of our reverse engineering and testing of this device, and kind of knew really well what the components of the device were, what security mechanisms were installed. And so and one thing we see with the attack is we see a lot of organizations using heat maps to track how well their organization tracks different adversary tactics and techniques. And so we wanted to pilot out what that would look like for embed. And so what we did is we took the threats and we put them in this matrix, and each TID is a separate embed threat. And what we found is, a certain device didn't have certain features or capabilities, and so those TIDs here are represented in gray are not relevant. So you really don't need to worry about those threats if you're trying to understand the security of this device. And we saw that here in this kind of pink color, a lot of these devices, when we tested this, we thought the device had what we would consider a foundational threat for that. And so that would be an example of a threat that device has mitigated, at least to the foundational level. These kind of more purple colored ones are where there was a foundational mitigation, but it was dependent on a configuration. So it could potentially have been turned off depending on how the user used the device. And then these dark purple ones were threats where we didn't see any mitigation, right? And so the idea is that by looking at something like this, you can easily see like what threats are well mitigated, how well the device is doing overall mitigating these threats, where there might be some gaps. So here you can see obviously that the hardware lacks a lot of the hardware threats are not well mitigated, but generally the networking one is, and generally the application software is, except for a couple of different specific threats. So we're just trying to show an example of how you can think through using the properties to identify what threats are relevant, and then using the mitigations to track, how well those threats are mitigated in a device, and where there might be needs, both areas where additional mitigations can improve the security of the device, or what, if you're an asset owner, understand, how do I better protect against these threats, knowing that they're not adequately protected in the device.
So that threat modeling is a really good use case. Another use case that actually someone, a product security professional from a vendor shared with us, which I think is great, is using embed to understand your attack surface. And this can be particularly useful for helping justify investment in product security. So what this use case is, take all of the vulnerabilities that have hopefully publicly been disclosed, but take all of the vulnerabilities over the past X years for a particular product and use those vulnerabilities and then map them to embed threats and properties. And so what you can do then is you can look at the properties that kind of like the heat map that Adam mentioned, that are creating the most vulnerabilities that you need to patch and address. Consider, do you really need that Bluetooth connectivity? or at the very least, informed discussions about when new features get added into products with this data. And at the same time, you can take the threats from the CVEs that have been disclosed and use it to look at mitigations, both foundational, intermediate, and leading to help, mitigate those threats directly now, but in the future. And so the next slide kind of shows a very simple example of this in play. So this is a CVE that I think was pretty recently disclosed. So what you can do is you can take your vulnerability disclosure. This was a 9.9 in an Avanti product. And Embed has mappings of threats to CWEs. So you can take the CWE number, search on the Embed website, and you'll find then that CWE 121 maps to TID 202, exploitable system network stack component. And then you can then look at the mitigations. And here you see there's both foundational, so something you can do today at or intermediate or leading mitigations to help mitigate these threats. So I'm certainly hoping that product teams can use this to advocate internally for building more security into products in this manner. So that's understanding attack surface. I think another good use case for security researchers now, if we put on a security researcher hat, is the device property, the threat mapper that Adam shared is another great way when you're doing assessments of devices to explore what potential threat avenues and research avenues you can explore based on the properties you see on the device. So this example here shows selecting a couple of properties. So by selecting these hardware properties, you can then automatically see what threats exist in the embed knowledge base. And then you can decide, let's say the device does have a hardware access port, it has UART or JTAG. You can then try to extract the firmware via the hardware interface or through that debug port. And so this is also a great way because then when you have security findings, you can then use the threat ID to communicate the finding. And that way it immediately maps to the properties, but also to mitigations that the vendor can build in. So Revolut currently using Embed on commercial assessments and also on some like government assessments, so on the DARPA Approvers Program as well, to help kind of bridge the security researcher gap to identifying mitigations that could, help mitigate not the specific finding, but the class of findings, and as well as understanding what properties are exposing these vulnerabilities.
Yeah, and one other use case we now talked about use cases from the device manufacturer, use cases from the researcher, security researcher, and then the kind of the third area of research use cases we proposed was really on the asset owners, and really one area where we see that is using embed to better inform like product documentation of properties and mitigations, and really the reason we said that is one of the challenges we have is if we do a lot of analysis and testing of devices. And one of the challenges is when you get a product and look at the documentation, it typically lacks really any detail that would sufficient detail about the device does that really would inform like what threats would be relevant to that device and the ability to evaluate whether, often what the mitigations are or whether those mitigations are necessary. And one thing, we're tracking the EU CRA. We're getting asked that a lot because that's going to influence the design or identify requirements for any device with the digital element. And so what that does is it has like Annex 1, which identifies a set of general security requirements that all devices with the digital requirement are required to have now. But what that really says as well is that there needs to be technical documentation that shall contain the relevant data or details that the manufacturer used of that product to ensure those security requirements are deployed, right? And so you actually have to have documentation that informs that those it helps it provide information that those security requirements were met. And so really what we're saying with embed though is if you want to understand, what security requirements are met, you really need to understand, the specific properties of that device, right? So the embed properties are critical to understand, both what threats are going to be relevant to that device, and then what mitigations are defined. And so we just think that by defining the properties of the device, in addition to the mitigations that device, and potentially aligning them with embed, provides a more systematic way for asset owners to understand, what does the device do, what threats are going to be relevant to the device, and how do I know that the device has mitigations for those. So it provides a more consistent way and easily and verifiable way to understand whether a device has a required security requirements or security mechanisms met. So that's an overview of what MITRE embed is, and some use cases about how both how do we see our organizations currently using it, and how maybe we can see, and also some potential new use cases for the future. Um, we released version 1 of embed last, I think it was October, and we're planning version 2 this upcoming April. So here in a couple of months. And so really what we're trying to do with that new version is one thing we've been asked a lot is for more tools to help use and integrate it with other services and tools. So we're looking at adding the a Stix API, so JSON-based representation of embed, so it can be ingested into tools. We're looking at adding some other spreadsheets that can be used to help interface with it as well. And then we're working on expanding and some of the properties, threats, and mitigations based on a lot of really great feedback. We've been getting a lot of great feedback from industry, and trying to tailor towards that. We're also, our goal with embed is really to try to make a knowledge base that industry really uses and finds valuable. So we're really looking to industry for feedback on their use of embed. We're trying to get as much feedback as we can, looking, understanding different use cases in addition to ones we've already identified, and understanding how can we make embed more useful to you and help it make help both make it easy to develop secure devices and evaluate and verify the security of devices you're buying or integrating. So that's what's kind of on the horizon for embed. So that's really an overview of embed. That's really what we wanted to present today. If you want to reach out to the embed team, we have an email at embed@mitre.org. But that's the end of our talk. So I think we have some questions in the Q&A. So we'll try to address those now. Let's see.
While you're looking at that real quick, Adam, if you don't mind, I'm just gonna light a final bit of color here. This is the common language for all of us to talk across these things across all areas, whether you're the researcher, you're the OEM and the vendor, if you're the defender, you're the industry operator. It is the common language we can all use to discuss this. In the end, in the industry, and something I've had experience with, I can say that this gives you the ability to know and to ask, like, what's going on with this device that used to be seen as a black box. It's no longer the black box. You can be able to start seeing more insight into what the attack surface looks like in these devices. Again, going back to when they go and get deployed and they're out there for years or decades, this is more critical than ever that we accelerate the maturity of this space exponentially. So we implore everybody to use it to really put it through the runner. If we're not improving and adding threats and mitigations, then we are not keeping our hand on the dial. Yep. And ultimately, we don't want this to be dated information. This needs to stay current. It needs to help pull standardization to current. It needs to help pull any kind of certification to current measures. Because what we can't have is another iteration in the next 10 years of really dated information and just being behind. Anyways, Adam, do you want to jump in with the questions?
Yeah, thanks now. Yeah, I think just kind of we'll walk through them. The first one from Delara, what's the best way to to download threats? Well, right now we do have a good hub page with all the threat data on it, that's used to generate the site. And so that's probably the best way now. But as I mentioned before, we are adding other ways to do that, including a JSON for that, 6JSON.
So real quick, there was some discussion about like, interfacing and being able to download this and get, better access to some of this data.
Yeah.
Please know we grew this organically. There's a lot of blood, sweat, and tears that went into this with no funding. And what I say and why I say it this way is because we needed to put forth this idea and the foundation of what is needed, and then have the community weigh in and say, okay, yes, we see that calibration, we see where this is going to work, and this is what we're going to need from it in order to be more successful using it. We also want to calibrate that no one runs off with this and just creates a marketing ploy, right? This is around the things that can hurt and harm and kill people. So at the end of the day, being very succinct in the way that you're addressing using embed and where it applies, again, it's embedded systems. There are other use cases you could do doing the reverse, looking at it in threat intelligence. Absolutely can do that. I have a background in cyber operations. I ran American Express globally. Like I can tell you there's ways you can do it that way, but that was not its purpose. So in the end, just know that we will get to the maturity that you're asking for in some of these things, but ask. The more you ask, the more we record those asks, the more that we have a foundation to be able to show this is what people are looking for within this space.
Yeah. Thanks, Clay. Yeah, I think there was a good question here from Philip Fisk about risk acceptance criteria. And what we're trying to do really there is we're trying to provide this objective knowledge base of the threats, and we are working across. You mentioned the medical device space. We're working with we've been a little bit with some medical companies, device companies. We're working with automotive companies, some aerospace, industrial control systems, and so what we find is there's a lot of industries that have their own unique perspective on how they do this, and so we think organizations or industries are going to do this the best themselves. And really where we see embed contributing the most is providing this kind of evidence-based, knowledge base to uh, a set of threats and mitigation so that they can better make these risk-based acceptance criteria. Yeah, regarding whether embed is a good framework for TRA on embedded systems, that's something I don't think we've worked through that exact case study yet. So we have done it with organizations doing using it in some similar processes, but those are the kinds of questions that we're um, trying to address and trying to understand how well it fits with those. So if you have questions like that or specific use case, we're happy to discuss that with you more, and please reach out to us.
And I think it's worth clarifying that in the phase 3, so phase 1 you guys saw last year, phase 1 and phase 2. The phase 1 was the actual properties themselves and the threats, and then we got to the mitigations. The phase 3, which we're in right now, was meant to crosswalk this whole framework through all the various parts of critical infrastructure embedded systems, and automotive is one, aerospace is another. So we are wanting to go through each of those areas and have a deep amount of crosswalk and be able to see, have we made this as not agnostic as possible to be able to address every area that we have in between, or do we need to give additional guidance around that? And so we have done some work already in the aerospace, as Adam has talked about, and others. But I just wanted to call that out, that we're planning to get there.
Yeah, and I think similar, Paul Lambert asked, how well can this be made to map to the terror model requirements for automotive ISO 21434 applications? We're not, we don't have a lot of, we know some, again, automotive oriented organizations are exploring this, manufacturers, but we're not, I mean, we're not, I'm not exactly familiar with exactly the requirements of 21434. And one thing we're trying to do is not, we're not trying to, again, like I kind of mentioned before, like focus on any specific sector or the requirements of that. We want to provide this broad knowledge base, but we are interested in those kind of feedback. Like, how does it, if you're interested in adopting to that, we are interested in, trying to understand challenges in specific sectors in industry and trying to provide, guidance on those. So these are the kind of questions that we're trying to, uh, understand and hopefully follow up more with industry and have some more discussions on this. So yeah, if you're
Yeah.
interested in that, please reach out to us.
Yeah, and we had a call last month with Auto ISAC to talk about you know, I think that's where, Paul, we would look for your guidance on what makes the most sense so that Embed can leverage what you're already doing with 21434. Um,
Another great question from Adva. Also, is it possible to contribute to Embed? Definitely, yeah. So again, like we have the Embed email address. So if you have a question for us or a contribution, similar to MITRE Attack, we want this to be, an industry knowledge base, right? And so we want to take contributions from an industry about, what are additional threats, what are different additional mitigations, how can we tweak these? So we've already gotten a lot of feedback from industry on ways we can improve or expand embed, and we're continually interested in getting that industry feedback. And so if you have a question, a recommendation, something you think we should add, again, please email us, and we're happy to have that discussion.
I see a good question about uh, how embed relates to cloud security, acknowledging the fact that embedded devices are increasingly tying into the cloud. Um, I think I'd say that we certainly focused in the beginning with embed on covering uh, the threats intrinsic to the device itself. So I think one thing, if you look through the properties and the threats, there's a lot of focus on the hardware, software properties, and I think that's something that's worth considering. If you have specific examples of where there's a gap in embed because of not focused on cloud connectivity, that might be worth highlighting. And I think Adam can chime in here. What we don't want to do is there's a lot of good work already in cloud security, and there's like kind of decreasing utility from my perspective on just duplicating that in embed there. So I think if there's a balance that needs to be struck between the two of them, that's kind of how I think about it. And certainly the threats, especially the hardware threats, there's a lot of focus on gathering knowledge about threats that are unique to embedded devices. And that certainly was the focus up until now.
No, great. Thanks, Wyatt. Wyatt, great answer. Yeah, and I just want to know, hi to it. I know very well. So thanks for your question. Another question from Brandon. Will embed have a straightforward interface to understand time-based changes to the knowledge base, i.e., if I consult embed periodically 6 months, can the delta be presented? That's a great question. I mean, generally how we're planning to do this is just having a change log of what was changed. Probably will not be represented the interface. Uh, that's how we've done it, like with other knowledge bases like attack in the past. I think that's a great question though of how do we make it more um, usable. So if you have suggestions on that, definitely happy to have discuss those. But that's kind of our current plan is just to keep this kind of periodic change log. I know we're getting close to time, and I think we have a lot of great questions here. We'll try to follow up. We won't get all these answered right here on the call, so we'll try to follow up with them.
I just want to say thank you, everyone. Appreciate Wyatt and Adam doing this presentation. Appreciate everybody that's on the call. I got to jump, but thank you all and look for more updates soon.
Yeah. Uh, yeah, I agree. Thanks everyone. I really appreciate your time. And thanks for all the great questions. And we're really looking forward to more feedback from industry and discussions. If we don't get them answered, just please send them to the embed at mitre.org email address, and then we'll answer them there.